Alright, so in this video we're going to plot the shear force and bending moment diagram. So we're going to get to see whether or not the code that we wrote in the previous video had any issues with it. So we're going to use Plotly this time to do our plotting. Now, as I said at the start of this series, if you've done any courses with me or worked through any other projects, Python projects with me, you'll know that we pretty much always use matplotlib. It's probably it's probably the most widely used plotting library for Python, and it's great. I use it all the time. But I recently came across this other library called Plotly, and that's what I'm going to use in this project. I've only just started using this library. I literally came across it a couple of days ago, and I've been pretty impressed with it. It gives us a lot of additional functionality, particularly if you're used to trying to visualize the output of a structural analysis in Python, which is what I spend most of my time doing. The ability, even something as simple as the ability to have a little hover message come up as you mouse over your plot is huge. And so to achieve that without any extra coding straight out of the box with Plotly, for me, that's been one of the really nice features it has. So, like any library, you're going to have to install it, and it's not likely to be on your computer already, so you've got to install it. So you're going to have to open up a terminal. If you're on Mac, that's what I use. So you open up a terminal, and this is the command. So, I use conda to install all my packages. You can use pip, either, whatever you're used to using. And basically, you will just type this into your terminal and hit enter. And that will start the process of downloading this library onto your computer. Once it's on your computer, it's a straightforward process. It's just importing like any other library. But before I dive in and actually start just writing the code for this, I want to say a couple of things. Well, we're going to go over and just have a quick look at the docs for Plotly. But before I do that, I'll just sort of emphasize that you don't have to have any special knowledge to use this. I have no prior experience in using Plotly pretty much before this project. This was the first project I used it on, and I like it. The point I'm trying to make here is that all of the information you need is in the docs. Now, if you've been programming a long time, you know this already. You're used to going to documentation for various different libraries and digging your way through and finding what you need to find. But if you're new to coding, this might even be your first Python project. What I'm trying to say here is get used to this. Get used to finding a library. I found a few in the last few days. I have no clue how to use them, but I know they've got documentation. Some sets of documentation are better than others, but if there's documentation there, the expectation is that you'll just go there and read it and start playing around with it. And that's how you learn how to use a new library. Okay, that's the long-winded way of me saying don't be put off by the fact that this is something new. You just go to the docs. So speaking of the docs, right, the documentation for the library, you can just Google Plotly. You won't take you long to find it. But this is the hyperlink that is going to be included in this notebook, which obviously you'll be able to download. So it's just plotly.com/Python. Okay, so if I go to that link now, this is where it brings you. So this is basically a whole series of example plots in Python. So when you're learning to pull together a new plot, unless you're watching a tutorial like this one, where I've basically done the hard work already and working out how to do what we want to do. But the likelihood is that you're going to find yourself having to do plots, and you're going to have to work out yourself how to do them. And so you're going to come somewhere like this, and you'll find a whole range of different examples. And through piecing together bits and pieces from different examples, you'll work out how to do what it is you need to do. So you've got all the documentation here. You've obviously got your getting started, blah, 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 all down here on the left-hand side. One that you might want to visit here is the getting started, and in getting started you have the little bit around installation. So again, this is where I basically got the command. Now you can specify which version of Plotly you want to install. So the current one is 5.1.0. That might change depending on when you're watching this, but basically this is just a very quick discussion on how do you install it. It's one line. It's just a simple command in your terminal. So that is the documentation. I'm going to direct you there once you've finished this video and you've implemented these this shear force diagram and bending moment diagram. When you want to do your own plots, you can go to the documentation. Just to say, Plotly is free to use. It's an open source library. There is a paid add-on service that you can use if you want. It doesn't give you additional functionality in terms of plotting. I'm not even very familiar with it, but as far as I know, it basically allows you to host plots online. I could be wrong on that. Point is, it's not relevant for our discussion. We're able to use Plotly inside of our Jupyter notebook without any charge at all. It's open source. Right, so we'll assume you've installed Plotly. Now it's just a matter of using it. So the first thing we're going to do is import. So we're going to import Plotly as py. So this is just import Plotly. Okay, so everything in Plotly is a graph object, right? And so you know, the line that you add onto your plot, that's going to be a graph object. And so we need to import these graph objects, right? So it's a slightly different kind of, I suppose, paradigm, you might say, to plotting inside Matplotlib. It'll feel slightly different at the start, but it's still quite intuitive. So anyway, we're importing these graph objects, right? So we're going to import Plotly .graph objs, and we'll import those as geo, so we can just call geo dot and then whatever else we need after that. So this is going to be import graph objects. Now, if we want to do the plotting inside of our Jupyter notebook, as we do, we have to input the next line of code. Plotly by default will output your plot in a browser window, a web browser window. Now, we don't want that. I mean, that works fine if you're inside of an IDE, a different coding environment, maybe VS Code or something, and you want to plot a graph. You're not going to have the functionality here of your Jupyter notebook. And so you will need your graph to open in a browser window, but we want our graphs to be output directly inside of our notebook here. And so that's why we need this line of code. So py.offline.init_notebook_mode, and we're going to say connected is true. All right, so basically this is just set up offline plotting. Okay, so anytime you're using Plotly inside your Jupyter notebook, you're going to have these 3 lines of code. It's just your setup. Now you could have put these 3 lines of code all the way back up here at the top. I chose to put them down here because I didn't want to confuse the issue earlier on. All right, let's execute that. All right, that's all worked. So now we can go ahead and actually do our shear force diagram. So the first thing I'm going to do here is define the layout object. Remember I said everything inside Plotly was an object, a graph object, right? So I need to define a layout. And all this is an object. It's a data structure. And all it does is it holds all of the data that specifies the layout of our plot. So it specifies the title, the positioning of the title, the fonts I use, you know, all that good stuff. And again, for your reference to all of the different pieces of information that you can specify, you would go to the docs. Right, so define layout object. Right, so I'm going to define layout here. I'm going to say layout is equal to geo. Remember we brought geo in here. That was that guy there. So geo dot layout with a capital L. I'm going to, let me see, start a new line here, and I'm going to say title is equal to, now I'm going to open up a set of curly brackets, and now I'm going to start inputting a whole range of key value pairs, right? And so I'm going to say the text of the title is going to be shear force diagram. So what are we doing here? We're setting, yes, what I'm doing here is I'm setting the positioning of my title. So in fact, let's actually not do that to start off. Let's see what the default is. We'll come back and we'll make that edit at the end, right? But I just want to sort of show you what the default is, right? So we've got title. Let's come down and then specify the y-axis. So that's going to equal a dictionary, and in here I'm going to have title is equal to shear force. Let's specify, let me just sort out my indenting here. All right, let's have x-axis next, and we'll set the title for my x-axis. Now, another thing I'm going to set on my x-axis that I don't need to bother setting on the y-axis is the range, right? So I'm going to set the range on the x-axis. I just want a little bit of padding on either side of my beam, either side of my plot. So I'm going to set the range for the x-axis to be a -1, to go from -1 to whatever the span is plus 1. Okay, just gives me a little bit of extra padding. You'll see now once I plot it. And then I'm also going to set another option for the layout here, and it's going to be show legend. Again, you just have to, you know, when I wanted to work out how do I turn off the legend, I didn't know, obviously, so I just Googled, right, how do I turn off the legend on a Plotly plot? And sure enough, a minute later, you've got the answer. So that's how you do it, right? So show legend equal to false. That's okay. And then let's just close that bracket off. So let me see if I missed anything. Okay, we had a bit of an issue with brackets there. All right, now, so that's your layout object. So what have I done here? I've defined a layout object, and so this is sort of the structure that Plotly has for us. So we've got a title specified, we have a y-axis with some options defined within a dictionary, an x-axis with some options defined within a dictionary, and then I've set the legend, show legend, equal to false for this particular layout. All right, we're getting there. So the next thing I want to do is define the actual trace of the shear force itself. So we'll say line, I'm going to define line as being equal to another object, right, another graph object, but this time it's going to be a scatter graph object. And again, so it's the same idea now, right? You get the picture. You define your object and then you pass in all of the values that that object expects, right? So a scatter object expects a series of x values, and we're going to let those equal to our capital X. It expects a series of y values. Now, this is where we're doing the superposition, right? So we're superimposing all of the different values of shear force. We're summing up across all of the different rows. And so I can say sum of shear force. Okay, so that in that one statement highlighted there, that is us applying the principle of superposition and summing up or adding together or layering on top all of the different values of shear force for each data point that arose due to all of the different point loads, moments, distributed loads, etc. Now the mode for us is going to be lines. So you could have lines, you could have markers, or lines and markers. So we're just going to have lines. We'll want a name for this. We're specifying a name for this trace. So if we did have a legend, it would have it would show this name. So we'll say shear force. Let's specify the line color, and I'm just going to choose green. I tend to make my shear force diagrams green, and then I'll want okay, let's just leave that at that for now. Okay, before we add any other bells and whistles to this, let's just generate the figure, right? So I'll say generate and view the figure. All right, so we've defined a layout, we've defined a line that we're going to lay on top of that layout, and now we just have to actually build or generate that figure. So I'll say figure is equal to, again, another graph object, so go.figure this time. What does figure expect? It expects some data. So these are all the different things I'm going to add to this figure. Now for now, I'm just adding line. So you can kind of see this whole idea of objects building up. We built a layout, then we built a line object, then we defined a figure object, and we told the figure object, hey, you want to show that line object that we defined previously. And we also, our figure also expects a layout, and so we can let layout equal to that layout that we defined. All right then, and then if I want that to actually show, I want to type py.offline.iplot. Again, this is just one of those naughty little lines of code you just have to add at the end of each of your plots. Let's see what that gives us. Okay, so we have a bit of an issue. I've no closing comma. Let's try again. Right, I bet you I'm missing. Yeah. Let's try again. Jesus, did I get anything right in here? So, okay, we're missing a whole series of commas here. Excellent. All right, there we have it. Right, so there is sort of our shear force diagram. Well, it is the shear force diagram, and if we mouse over, we see we have that nice functionality, which I really, really like. Now, I'd like to add a few little bits to this. I'd like to add a thick horizontal line here to represent the actual horizontal beam itself. Or the axis, the x-axis. So that's the next thing I'm going to do. So I'm going to add that. I'm going to define. So below where I defined a line, I'm going to define another line. This one I'm just going to call axis. It's going to be another graph object of the scatter variety. All right, it's going to have x coordinates of 0 and span. It's just a straight line. Y is going to have coordinates of 0 and 0, and let me see, the mode is just going to be line, and then what color do I want it? Well, I'd like it to be black. Line underscore color is equal to black. Now let's not forget, we need to add that to our list of data, right? So we want to plot the line, we also now want to plot axis. Let's try that. Okay, I keep forgetting the commas. Let's try it again. Right, now what did we do wrong? Okay, that should be lines. Brilliant. Okay, so now we have this black line. And so you'll notice here we have a little bit of padding over here of 1 meter and a bit of padding over here on the right of 1 meter. If I didn't add that padding in, so if I didn't have that line there, you'd see that your diagram spans the full width. I like a bit of padding around it, so that's why I put that in. Right, the only other thing that I'd really like to do is I'd like to fill this in, right? I'd like that to be like a lighter shade of green and a lighter shade of green down here. And again, you know, how do you think I worked out how to do that? Straight onto Google and ask the question, how do I fill in? And after a minute or two, you work out that all you have to do is within this line definition here, all you have to do is come in and say fill to next y, or you say fill is equal to next y. I was looking at that for about 5 minutes trying to work out what is that actually saying until I worked out it was to next y. All right, so now we've set a fill, and now we just want to set a fill color. So that's the thing that can go in here. So we can see fill color is equal to, and we'll specify an RGB and an alpha, and we wanted green, right? So we want 0 for the red. We'll have 255, which is the maximum for the green. The blue can be 0, and now we're specifying the alpha of 0.1. Let's see, does that work? Excellent, and there you have it. So there's your shear force diagram. Now the only other thing that I wanted to do was, I don't like that title where it is, right? I want that title down in here over the center of this plot. This is now getting into absolutely non-essential little bits and pieces, but I like to get the plot looking just the way I like it. So where I was defining, not here, but here where I was defining the title, right? We defined the text for the title. And before we close those curly brackets, I'm going to come in and then I'm going to define another series of things, right? So I want y to be defined here as being equal to 0.85. I want x to be equal to 0.5, right? So the y 0.85 here is saying that you want the title to be 85% up from the bottom, and the x is saying I want the horizontal position to be 50% over to the right of the plot. And now let's specify the x anchor and the y anchor. This can be center. Oh yeah, you guys spell it differently, center. And let me see, we want y anchor to be top. Right, so provided I've made no typos in there, we should see that this title now moves over to the center here. Let's try it. Excellent, so there you have it. So that basically is our shear force diagram. Now we have, because this is a plotly plot, we have all these little tools and widgets up here, right? So we can zoom in by clicking and dragging. Like, that's great. If you're used to trying to plot everything and visualize everything with Matplotlib, just even this little functionality is fantastic. Double clicking on this brings us back to the default zoom level. Obviously you've got all the tools that you'd expect. They all do what you'd expect them to do, right? Zoom in, zoom out, pan, click and zoom. You can download the plot as a PNG, go back home. The axes have this other nice little feature, right? So if you grab on the top of the axis here where that arrow is and pull it, you can drag and change the scale of the axis, which is really handy. If you were to click and drag down near the center where we have a double-headed arrow, you can pull your axis up and down, so you can move your axes around very easily. So it just makes interrogating and investigating a plot very, very straightforward, very intuitive. So that's why I like it. You're probably going to see me use Plotly an awful lot more going forward. All right, so now with the shear force diagram done, that's 95% of the work done, we can go ahead and work out or write the code for the bending moment diagram. So I'm going to, let me see, I'm going to be a bit lazy here, right? I'm going to take all of this code, copy it. I want to paste it in here, and I'm just going to then change bits and pieces. Right, so now what do I want? This obviously needs to say bending moment diagram. All right, and let me see, all this can stay the same. This needs to obviously change to bending moment and the units update. All right, coming on down, we now want to sum up all of our bending moments. We'll want that to be negative because we want our bending moment diagram to be positive downwards. And in order for that to work, up here in our y-axis, we need to add another little option. So we're going to say auto range, and we're going to set that equal to reversed. So this means our bending moment diagram will have the downward essentially pointing vertical axis will be positive, which is consistent with how we draw bending moment diagrams, or at least how I draw them. Let me see what else we need to change. Come down here. This obviously needs to change to bending moment. I like my bending moment diagrams red, and so we can set the green to 0 and the red to be the maximum value. And let me see if I've forgotten anything else. Well, let's just see what that gives us. Bending moments is not defined. What did I call that? Bending moment. All right, there we have it. Right, so there's your bending moment diagram. Excellent, and so we can hover over at the position of that point load and work out that our bending moment is 188.97. All right, now you'll notice that one of the issues with our approach to how we've built this shear force and bending moment diagram is that we're obviously calculating a single value of, well, let's think about shear force for a second. We're calculating a single value of shear force at each position along my structure. So that means when there's a discontinuity in the shear force diagram, i.e. when a point load comes on, and for a single point, we essentially have two values, the value immediately to the left of the point load and the value immediately to the right. Well, our code can't accommodate that. Our code can only accommodate a single value at each point. And so the way we've gotten around this is we've divided our beam up into tiny, tiny, tiny segments. And so for all intents and purposes, what you're looking at here is a vertical line. I mean, it appears as a vertical line, but in reality, it's ever so slightly sloped, because you have one value here, right? And then the immediately next data point, you have a different value, but that value has shifted across, right? 0.001, right? So where are we? We're at 0.9993 here, and then we come over to the next data point, which should be 6. So this should be 6, right? But it's 6.001, and this should also be 6, but it's actually 5.9993. And that's just because we can only accommodate a single value at each data point. Anyway, it's only a minor little issue. It's not really an issue practically at all. But what you can do to reduce it is you can divide your structure up into a smaller or a larger number of segments and a smaller distance between each segment. But for all practical intents and purposes, what we have here is absolutely fine. So just to be aware that we're not fully 100% accurately capturing the shear force and bending moment at discontinuities in those diagrams. Once you understand that, you're aware of that, it's not an issue. So there we have it. Our shear force diagram is done and our bending moment diagram is done. So now all we have to do is go through the process of taking account of point moments, distributed loads, and linearly varying distributed loads, and our bending moment diagram is going to update, and our shear force diagram will update in each case. So let's take a break. We have most of the hard work done now. Over the course of the next 3 or 4 videos, we're going to just build in our ability to take into account those different kinds of actions. But as I say, the bulk of the work is done.